Okay, so today is the first day of geometry, and we are going to start pretty simple. We are literally just going to do these first two things. We're going to learn how to measure with a ruler accurately, and we're going to learn how to measure angles with a protractor. So, first off, if you look around your table, there should be a ruler somewhere. My last class used them, so I told them to just leave them out for you guys. So find yourself a ruler, and then what I would like you to do is pull up this paper that I gave you. And we're going to talk about the very specific requirements for measuring accurately. Because whenever we are measuring, like if you're measuring something at your house, you're like, okay, I need something that is like this long. We don't have to be as exact. Hello, how are you?
Hey, I'm looking for my name. Where my name at?
For your name. I would like for you all to look at the very first line in the top left-hand corner of that paper I gave you. Now, these are called line segments. Okay, line segments. A segment is just like a piece of a line, just a piece of it. Does anybody know why we need to specifically call this a segment rather than just a line? Anybody know?
Because it stops.
Yes, it has stopping points. A line never ends. The definition of a line is it's just points that are going in opposite directions forever and ever and ever, and they never stop. A segment is just a piece of that line. So this is a line segment. Now, we're going to measure it. So, look at this paper I gave you. It says the giant inch. Okay? Basically, what this is it's a guide for how we use a ruler. In between every inch, there are all these little tiny tick marks on a ruler, okay? And you'll see that on the rulers you have. You see that there is a 0, a 1, and a bunch of little tiny tick marks in between. So what is happening there is we are separating that inch into fractions of an inch. So we've got our halfway point, we've got our 4th point, we've got our 1/8, and we've got it separated all the way down to 1/16. So little teeny tiny fractions here. So whenever we are measuring something, if it does not fall exactly on an inch, so let's look here. First of all, when we're measuring with a ruler, does anybody know where our starting point is? Is it at the end of the ruler, or is it at that first line?
First line.
Yes, it is at the first line. If you measure your object like this, I know it's a very slight difference, but if you put it at the end, you are not going to get the correct measurement. It needs to be right there. You guys see that difference? So basically your line needs to line up on this outer edge, and you're measuring to this outer edge. So let's look. I'm lining it up there, and I want to see where this is gonna end. Okay, so let's see. I've got 1, 2, almost to 3. Is this line 3 inches? No, it's not. So this is where we would need to use our fractions to figure out the exact value of the inches here. It's going to be 2 inches and something, some fraction. So let's look on our little guide. We'll count our dots. So here's my halfway point right here in between 2 and 3. And I'm going to count from there and see how many places over we go to. It looks like it's going to be at this line. I'm going over 1, 2, 3, 4, 5, 6 spaces over from 1/2. Or I could say, since it's closer to 3, how many spaces away from the 3-inch mark is it? And I would say it's 1, 2 away, right there. So on my giant inch, I would start here and see where is that point. I've got 1, 2. It fell on this line at the 7/8. Okay, so that would mean that this line should measure about, or this line segment, about 2 7/8 of an inch. We would write that like this, 2 7/8 inch. Okay?
Alright.
What's up? Are we confused? Tell me about it. I love questions. What's got you confused?
It's not really like confused, I'm just relearning.
We're just listening, but I mean.
I get you.
I mean, because we didn't listen in geometry.
I get
It's always
you.
somewhere chit-chatting or
That's
somewhere
all right.
in the hallway.
That's all right. That's why we're here now. I love it. We're here. Okay, so the main point to take away is your starting point on a ruler is that first line. And wherever we end, the very outer part of our end point is going to be where that falls onto the other line on the ruler, okay? And we just need to remember that we've got little fractions in between here. Now, whenever we eventually quiz, or like take our first geometry quiz, where are you going to see this? I will tell you, the first question on your quiz, there will be a line. I'm going to tell you to measure it. You will only have to do it once. So you want to be very accurate with it. You just want to line it up real good and carefully count those tick marks to make sure you're getting the right fraction. Keep this paper. You can always use it as a reference, okay? Keep it. That way you can look back and make sure you're getting the right fraction. It is not absolutely life or death that you memorize these fractions, because I think in real life we don't use these often unless you're like a construction worker or you're like writing out plans for a home or something, like a blueprint. In the real world, we'd probably say it's almost 3 inches, or it's like 2.8 or something. We don't use the fractions much in real life. But for the purpose of this class, that's how you do it. Let's do another one. How about this little tilted line segment underneath? I want you to line your ruler up as accurately as you can and see if you can tell me a super accurate measurement of this segment down here. And can I make it not blurry? There we go. And I'm going to measure it too, and we'll see if we get the same. Okay, guys. What measurements are y'all getting? Once you think you've got one, shout it out at me. What'd you get? 2 5/16. Anybody get something different? Did everybody get exactly 2 5/16?
Which one?
For this one underneath this like tilted one right here. I should have numbered these.
For some reason, I got 2 3/8.
2 3/8. Okay, so let's write down the different answers we got. And
We split close.
okay, so you said 2 3/8.
Yeah.
Okay, so 2 3.
I don't know what's really accurate if everybody gets something different.
So we're gonna talk about it. 2 3/8. 2 5/16. Did anyone get numbers different than that? So did everyone either get 2 3/8, 2 5/16? Everyone got one of those two? Okay, so let's look at this together. Okay, remember our starting point on our ruler Come on. Man, get clear. Okay. Our starting point is that first line that we see. Where should I line this up with on my line segment?
At the beginning of the dot.
Yes, at the very beginning of the dot on the outer edge right there. You see that? Okay. Then I want to line up the rest. And let's see. So what I did here is I marked on my paper. Here's where 2 inches is. And then past 2, I've got 1. You see that? 2, 3, and 4 right here. I'm on that 4th mark, maybe even 4.5, but not quite to 5. We'll say 4-ish. So 2 inches and then 4 tick marks. Does everybody agree with that, or are you seeing something differently? Okay, so good. We've got 2 and then 4 tick marks. So let's look at our chart and let's see what that would give us. So here's where our inch would be. We've got 2 right here, and let's count our 4 tick marks. 1, 2, 3, 4. Okay, so everybody got all the way around 1/4. I got 3/16 and 5/16, or no, 3/8 and 5/16. Okay, so we're getting slightly larger measurements than I got. Did everybody count 4 tick marks after the 2, or are you guys seeing 5 and 6 tick marks after the 2?
I just saw one a little past, so I like rounded up.
Okay, round it up. Okay. Okay, so round it up. That's how we got that answer. How about the 3/8? Who got 3/8 for that one? 2 and 3/8. Somebody said it. I don't remember who though.
I did.
You did? So Cheyenne, what did you do to get 2 and 3/8?
I don't know, I guess I was counting like the lines wrong.
Uh-huh.
I don't know.
Do you think, go ahead and line your ruler up on there again. Do you think that maybe you had your starting point slightly too far back?
Yeah, on the 3rd one, where it says 0 inch, right there where it goes, no, on the ruler,
Uh-huh.
where it says 0, and then there's one like that goes down there by it. So I guess I'm just doing that in the wrong spot.
Okay, so, let's see. I wish this would get clearer because I want it to be really zoomed in. There. Okay, so we're here at our starting point. Ooh, so accurate. And then, Cheyenne, what were you saying just a second ago? What'd you go to?
Like I do it where it's supposed to start, and I get the right answer. So
Okay.
I'm doing it at the 2nd or 3rd one.
Oh, so do you think you accidentally had it like here?
Yeah.
Gotcha. Okay. So does everyone see how we're getting the 2 and 1/4 inches as our answer? Okay. And then I want to keep track of time. It is 3 o'clock, so if you need to go, that is totally fine. Okay.
See you tomorrow.
See ya. Okay. So that's how we're using a ruler, guys. Not too difficult. It's just that we have to get used to being as precise as possible. In geometry, in math, we want precision. We want exact answers. So that's where it can be the trickiest sometimes, is just taking your time with it, going slow, not just throwing it on there and saying, oh yeah, it's about 3 inches. We want to go real slow, real precise. Check very carefully to try to get that correct answer. Okay? Does anybody have any questions about using a ruler at all? Does everybody understand how to do it? Okay. We're going to introduce one more thing today, just quickly. I would like for all of you, I'll go ahead and grab them. We are going to use what's called a protractor. protractor today. So if you want to just take one, pass it around, and then flip your paper to the other side, where you're going to see some angles. Okay, so everybody, this is a protractor. Everybody say protractor. Thank you. So a protractor is what we use to measure angles. It is like a ruler for how large an opening is. All right, so whenever we are looking at an angle and we are trying to measure it, we also need to be very, very precise. Geometry is always precise. So you're going to notice on your protractor, we have at the bottom in the middle a little hole and a line that goes straight up and down, a line that goes straight left to right like this. We are going to use this as our starting point. So when we are measuring an angle, I'm going to explain what I mean. We have two lines here that come to a point right here. This point is where we start from, and this point is called the vertex. So everybody say vertex. Has anybody never heard the word vertex before? Never heard vertex? Well, this is a vertex, a point. So our vertex is that starting point of our angle. What that basically is we can imagine an angle like a book, opening and closing. Like if I have, here, let me grab a book. If I have a book here, like this, and I'm gonna do this, and I open and close the book, like this is my vertex. This is the angle getting bigger, bigger, bigger. This is the angle getting smaller, smaller, smaller. So what we're really measuring is how large the opening is getting. Okay, so if this is our book right here, we're gonna say like this is the part of the book that's resting on the table. So we're gonna line our protractor up by putting the vertex in that little point, and you want your line to line up perfectly with the edge here. Now right now mine's not lined up perfectly, just by the tiniest bit. This is going to give me an inaccurate reading. You guys see that? I need to shift it up the tiniest bit so that it lines up right with that first point, that first little tick mark where 0 is. Okay? Now you're going to notice around the edge of this protractor there are two sets of numbers. There are some numbers on the outside. There are some numbers on the inside. Which set of numbers do you guys think that we are going to be using to measure this angle? Outside. The outside? Yeah. Anybody else agree? Or do we think inside? Okay, so I'm getting both answers. Why do you guys think it could be outside versus inside?
I just guessed.
Okay, you just guessed. I appreciate the honesty.
I think it's inside because the angle is like acute or like small.
Ooh. That's a good word to know. Acute angle, yes. So this angle, we're going to start with the inside numbers. And I want to give you a really good explanation of why that is. So I want you to think about this like the book reference that I just told you. When we are opening this book, my goodness, if I could get this to stay still. When we are opening this book, the angle is opening up this way. Okay, so when the book is closed, we have a 0 degree angle. 0. There's no opening. As it gets bigger and it opens more, the number starts to go up. So you see here we start at 0 and then we get to 10, to 20, to 30, to 40, 50, 60, all the way around.
So what's the other number?
The other numbers are for when an angle is opening in the different direction. So whenever I were to put my protractor here and measure this angle, now I would use the outside numbers because it starts at 0 here and it goes up slowly to 10, 20, 30. Keep going that way. Does that make sense? Okay, good. So let's look at how we're going to measure this now. And again, we want to be so precise. We don't ever guess. So we're going to look here. We're going past 10. We're going past 20. We're going past 30. We're going past 40. Okay, so we're not quite to 50, are we? Not quite. So what I'm going to need to do is count these tick marks on the edge here. So I'm at 40. You see how I'm tracing this line here? This is where 40 is. It lines up with. So I can count 41, 42, 43, 44, right at 45. That's exactly where it hits. So we would say that this angle, I would make a little arc right there, and we would say this angle is 45 degrees. We measure angles with degrees, and we abbreviate degrees with that little circle above the 45. Okay. Is anyone confused about how we figured out this is 45 degrees with our protractor? Okay, let's do another one. Let's look at one that's a little different. The one right below, we have an angle with a much bigger opening here. And it's not sitting flat on the table, it's tilted. So first of all, where is my starting point for measurement on an angle? What's that fancy V word name I just gave you? The vertex. That's your starting point, the vertex. So I need to line my vertex up with my circle. Okay, am I good to measure it now? No? Why not?
It needs to start at the 0.
Yes, I need at least one of the sides of my angle. One of these lines needs to line up with 0. Okay, so it don't matter which one. Maybe I could go like this. Now here's another issue. Am I positive that this line is lining up perfectly with 0? Am I positive of that right now? No. I can guess like, oh, it looks like it's going to hit 0. We don't ever want to guess in math. Ever, ever, ever. We don't ever want to guess. We want to be so precise on everything that we can be. So in this scenario, it would be a good idea to extend our line. Now, again, don't guess. Even on those line extensions, you want to use a straight edge, okay? So this is where you could use your protractor as a straight edge. Line it up, and let's just make these lines a little longer. And I'm just going to do it to both of them, just to cover my bases in case the other one isn't long enough to make it longer. Okay, you guys see how I extended those lines? Okay, once your lines are extended, we can go ahead and line our protractor up with our vertex again. And this time we can be certain that we're starting at 0, because now I have a line that will touch it for me. Okay, so whenever I am measuring this angle, shout some numbers out at me. How many degrees is this angle? Ooh, two different answers. 70 or 110? Which one is it? 110? 70? Okay, let's talk about it. Let's talk about it. So we have an angle, and our starting point is here. Okay? You guys see that? We put our vertex here, but when the angle is closed, we're lining it up with 0 on this side. You see that? Since I'm starting from 0 here, what makes more sense? Going from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? Or go from 0 to 179, 178, 177, 176, and keep going which way?
First.
The first one. Yeah. You want to start, say it again?
So it's 110.
It's 110. Yes. We want to start measuring from whatever side is pointing to 0 and count with the numbers that are going up in value. We also know that this is going to be bigger than 70 degrees because, first of all, do you guys know what a right angle is? If you don't, that's okay, but awesome, it sounds like some of you do. A right angle is any of the angles that are usually seen like at the edge of a paper, usually the edge of a table. Right angles are a perfect 90 degrees. So if I were to measure the angle of this edge of the paper right here, when I line it up with 0 and the edge of my paper, I've got a perfect 90 right here. 90 is going to be that perfectly straight up and down line. So when I'm looking at this angle that I'm measuring, if I make this flat here, I know that 90 is always going to be about like this. This is an estimate. Going straight up and down. There's my 90 degree angle. So from here to 90, is this bigger than 90 or smaller? It's bigger than 90. So if we're trying to reason with our answer and we can't decide is it 70 or is it 110, we can think about it visually too. I see that this, and obviously I didn't draw that perfectly, but this angle is bigger than 90. So it can't be 70. It's going to be 110. Because now I've got it flipped. I started over here, counted 10, 20, 30, 40, blah, 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 up to 110. Okay. Does that make sense, you guys?
Yes.
Okay. Awesome. So we'll label this one also. We will call it 110 degrees. Perfect. Okay, guys. That is really everything that we were able to cover in first period. We're not going to get too into anything else. So, your first assignment. Here's what we will do. Your exit ticket today is on this paper that you've been working on. I need you to measure and label this angle, the bottom left one right here, under the 110. And then I want you to label it with that little arc and write how many degrees. Be as accurate as you can. Remember, extend the lines if you need to. And I also want you to measure on the other side the smallest line segment on the page. That's this one right here. Again, be as accurate as you possibly can be. Take your time with it. So those are the two measurements I need you to give me. And it's going to be this bottom left angle. I want you to measure how many degrees that is and label it. And once you finish measuring those two, I need you to write your first and last name on your paper somewhere, and then you are going to turn it in right up here. This is where we turn papers in, guys, at the front of the room. Right here. This is your turn-in bin, and it will always be right here next to the board. Once you turn that in, you're free to go. That's it today, guys. I'm going to stop this recording.